In this video, we will learn about combination of resistors. First is resistors in series. Given figure shows a series combination of three resistances R1, R2 and R3. Here we can observe this is R1, this is R2 and this is R3. All the three resistors are connected in a series and we can observe that same current will flow through all the three resistors. In series arrangement, there is a single path and hence same current flows through all the three resistors when a battery supplying a voltage V across the combination is connected. Here we have three resistors in series, that is R1, R2 and R3. We know that potential difference of R1 is V1, of R2 is V2 and of R3 is V3. We also know that potential difference V is equal to current I into resistance R. But in the case of series connection, current I is going to be same through all the three resistors. So we can write that VI is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. So this is given over here, IR1, IR2, IR3. We know that total potential difference across the entire circuit, that is V, is going to be equal to V1 plus V2 plus V3. Now we can substitute the values of V1, V2 and V3, that is IR1, IR2, IR3. So we can write that V is equal to IR1 plus IR2 plus IR3. If Rs be the equivalent resistance of series combination, so we can write that V is equal to I into Rs. Now we know that this I could be cancelled out and we get Rs is equal to R1 plus R2 plus R3. So final is that equivalent resistance in series combination is equal to sum of resistances of all the resistors. Here we have some important conclusions. From the above discussion, we conclude that for a series combination of resistors, same current flows through the entire series circuit. Total potential difference across the series combination of resistors is equal to the sum of potential difference across the individual resistors, that is V1 plus V2 plus V3 and so on. The equivalent resistance in series combination of resistors is equal to the sum of individual resistances, that is Rs is equal to R1 plus R2 plus R3 plus so on. Next is the equivalent resistance in series combination is greater than any individual resistance. Let's take an example. If R1 is equal to 2 ohm and R2 is equal to 3 ohm, then the equivalent resistance will be R1 plus R2, that is 2 plus 3, which is equal to 5 ohm, and this 5 ohm is greater than 2 ohm and 3 ohm. Next is, if n resistors, each of resistance R, are joined in series, then equivalent resistance Rs is equal to n into R, where n is the number of resistors and R is the resistance. Now let's understand disadvantages of series combination of resistors in electric circuits. For circuits employed in our daily life, we do not prefer to use series combination of resistances due to the following reasons. First is, in a series circuit, same current flows through different elements of the circuit, which is impracticable. For example, we cannot connect an electric bulb of 100 watt and an electric heater of 1000 watt in series because they require different currents. Next is, In a series circuit, if any one component fails, the entire circuit is broken and none of the components of the circuit works. Third, in a series circuit, it is not possible to put separate on-off switch with each appliance or component. Moving ahead, let's understand about resistors in parallel. Consider three resistor resistances R1, R2, R3 respectively connected in a parallel combination between the points A and B as shown in the figure. So this is point A and this is point B. Here we have three resistances R1, R2 and R3, and we can observe that current flowing through all these are different. Let us connect a battery of voltage V across the resistance combination. Obviously, the potential difference across each resistor is V. Then current flowing through the individual resistors are I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by I3. Because in this case, current is different but the potential difference is same. So total current in the circuit is equal to I, which is equal to I1 plus I2 plus I3. Now let's substitute these values in place of I1, I2 and I3. On substituting the values we get V by R1 plus V by R2 plus V by R3. If Rp be the equivalent resistance of parallel combination, then the total current in the circuit is I, which is equal to V divided by Rp. So we know that in place of I, we can write V divided by Rp, and from this V can be cancelled out, so we get 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Here we have some of the important conclusions. From the above discussion, we conclude that for a parallel combination of resistors, first, potential difference across each resistor is exactly the same and equal to the potential difference across the combination. Second, total current through the parallel combination of resistors is equal to the sum of individual currents through various resistors. Thus, I is equal to I1 plus I2 plus I3 plus so on. Next is the sum of reciprocals of individual resistances is equal to the reciprocal of equivalent resistance of the parallel combination. That is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Next point is the equivalent resistance of parallel combination is lesser than any individual resistance. Let's consider an example. So consider R1 to be 2 ohms and R2 to be 3 ohms. So the total resistance in parallel 1 upon Rp is equal to 1 upon 2 plus 1 upon 3, which is equal to 3 plus 2 divided by 6, which is equal to 5 by 6. So Rp is equal to 6 by 5. On dividing it, we get 1.2, which is less than R1 and R2. Next is, if n resistors, each of resistance R are joined in the parallel, then the equivalent resistance of the combination is given by Rp is equal to R divided by N. Next is, if two resistances R1 and R2 are joined in the parallel, then equivalent resistance Rp is given as 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Rp is equal to R1 into R2 divided by R1 plus R2. Seventh, resistors are connected in parallel if the effective resistance of the circuit is to be decreased. Eighth, all the electrical points or appliances in a domestic electric circuit are connected in a parallel combination only. Moving ahead, let's understand advantages of parallel combination of resistors in electric circuits. In a domestic electric circuit, all gadgets and appliances are invariably connected in the parallel arrangement on the account of following advantages. First, in parallel arrangement, equivalent resistance of the circuit is reduced and we can draw more current from the given voltage supply. Second, in the parallel arrangement, the total circuit current is divided through various branches or appliances, hence each appliance draws appropriate current as per its operational requirement. Third, in the parallel arrangement, separate on-off switch can be employed with each appliance. Fourth, in a parallel circuit, if any one appliance fails, we can still use the other appliances. I hope this topic is clear to you. Thank you.